I'm here in Technibond's laboratory today and I want to run through some of the testing that we do. Firstly, I should point out that this laboratory is air conditioned, temperature controlled to 23 degrees C, which is the industry standard. The reason for doing that is that adhesion testing, or tape testing, is very sensitive to temperature. So if we didn't have this room temperature controlled, then the test we did in the morning would be different to the afternoon, one day would be different to another. So for consistency, we have this very close control. The first test that we do is shear testing. Shear testing is literally hanging a weight on the product. And what this really does is to measure the cohesive strength of the adhesive, and that's the long-term, its ability to withstand plastic flow. So shear testing for us is probably the most important of the adhesion tests. It's the one that gives us the best indication of the long-term capability of the adhesive. We tend to do these tests a little bit differently to our suppliers. It's the same test, but bear in mind that all of the adhesion tests were developed and are mainly used for quality control testing, which is a short-term test. We do these shear tests sometimes for months on end because we're interested in the long-term performance of the adhesive. But essentially it's the same test and it's measuring the cohesive strength of the adhesive, which is one of the two main adhesive performance characteristics. The second of the main tests that we do is adhesion testing. So whereas shear measured cohesion of the adhesive, the adhesion test measures the adhesion, and that's the bond strength, the strength at which the material sticks to any other surface. Now, as an industry standard, we use stainless steel. The reason stainless steel is chosen is basically because it's a very controlled surface. The material, the finish can be closely controlled, and it's very easy to clean, or it can be cleaned quite rigorously so you get the same test results each time. Unfortunately, not many of our customers are sticking to stainless steel. So one of the things that we do separately or differently to other people is we also run a lot of these tests on customers' own materials so that we can show people how our products perform on their materials rather than on stainless steel. We just run through a quick test to show you how it works. So the standard industry adhesion test is what we call a 180-degree peel adhesion. It's done, as I say, to stainless steel, and it's done in this tensometer. And the top jaw of this is attached to a load cell, which very accurately measures the force as we peel this tape from the stainless steel. So we run this test at a set speed, 300 millimeters a minute. The machine continuously measures the force that's produced as it peels, and at the end it'll give us a readout with the averages, the standard deviations of that force. And then typically we would do 3 or 5 replicas of this just to make sure we've got a consistent result. So that's the test finished, and on the screen we've got a readout of the profile of the peel with the average and the standard deviations, and then we combine several of those to get the average peel force for this particular adhesive. We also use our tensile tester with a much more sensitive load cell to measure release force, and that's the force that it takes to remove the release paper or the release film from the product. And of course there are two sides to this. There's the unwind of the actual roll of tape, and then there's the final removal of the release film or release paper from the other side. We don't necessarily want those two release forces to be the same, so we closely control both of them. And release force is particularly important with die-cut parts where you want the product to come off on one side and not on the other. So again, the release on the two surfaces has to be quite closely controlled to make sure that it's reliable in use. Right, I mentioned earlier that adhesion tape testing is temperature dependent. So we've got an oven that we use for high temperature testing, and not typically at very high temperatures, but often between 40 and 70 degrees C occasionally up to 100, 120, but often at relatively modest temperatures, because even at 40 degrees, the tape performance is quite different to its performance at 23 degrees. So we can put our shear jigs in this oven, do elevated temperature testing. We also use the oven for aging tests, so we'll age some of our materials long term. Particularly when we're making new constructions, we need to know that that's going to last for a year at least, sometimes more, and that the performance is consistent for a long time. And this is particularly important when we're putting different release papers, release films on products, to know that it's going to be stable for a long period of time. And just as tape performance drops off with higher temperatures, so it changes with low temperatures as well. And in particular, the tack of products varies with low temperature. So we use this cooled incubator to look at performance really between -10 and probably up to about 40 degrees. But at cooler temperatures, below 23 degrees down to 0 or so, the tack of the products drops off quite a lot. Particularly for people who are applying the products outdoors, different conditions, we need to know how the products will perform when somebody's trying to apply them at 5 degrees, at 10 degrees, at 15 degrees, because some of our products are going to work much better than others at those sort of temperatures. And finally, a bit of equipment that's not kept in our temperature control laboratory but outside, because it's got its own temperature control and because it generates a certain amount of humidity. We do a lot of outdoor testing, accelerated weathering, and we use this machine to measure the long-term performance of products that are going to be outside in the frost, the rain, condensation, humidity, all the rest of it. So this is an accelerated weathering machine, and by running a test on a material for probably 3 months or so, we can predict how well that material will perform outside for probably sort of 5 or 10 years. So it's a very valuable piece of equipment for all of our customers who are using products outdoors, for instance in the window industry, in sign industries, things like that, where it's constantly exposed to outdoor weathering.